I'm Wyatt. I've been at the Mining Remediation Authority, formerly the Core Authority, for those that don't know, we changed names last year. And I'm going to be talking about success rates of drilling into mine workings in Great Britain. So, coal mining in Great Britain. Firstly, we are at the Mining Remediation Authority. We are government funded and a non-departmental government organisation. And we manage nearly all the coal mining legacy in Great Britain. Since 2016, there's been no underground mines mining coal. Some are on care and maintenance. Mine workings range from surface down to about 1,000 metres below surface, and there are various types of mining techniques. We've got drill and store, where you leave a pillar of coal to mine the coal. We've got total extraction and long wall or short wall extraction, where you remove nearly all the coal as well. Coal mining in Britain dates back at least several centuries. We're going kind of back to the 12th century at least. Many of those mine workings are now flooded with mine water. So the pumps got turned off a few decades ago in most areas. And with the mine water, we've now got potential for mine water heating, cooling and storage. So if you're drilling boreholes, first question is, what is the purpose of drilling boreholes? You've got investigation into shallow mine workings or unrecorded mine workings. So you're going to build some houses or something. You want to check that out first. Exploration drilling, that was done for mining when mining was active. And the study we've done at the Mining Remediation Authority concentrates on when we've got boreholes used for monitoring or operational purposes. So that's pumping or discharging water back into the mine workings. You kind of got thousands of ones that are in investigation, and we've got tens of ones that are now into mining schemes or pumping. As David was talking about earlier on, different mine working scenarios, you've got different targets. So we've got underground roadways or galleries, which are tunnels underground. Pillar and store type workings, we've got roadways and we've got pillows. They tend to be older mine workings. And we've got total extraction, so you get areas of collapsed mine workings. And you can also have fractured bedrock or fractured geology above the mine workings, so you can kind of get some reasonable yields of flow from those. I kind of put them broadly into kind of decreasing likely yields you can get from those different targets. First question is, what is a success for a borehole drilling? First point is that depends on the purpose of the borehole. We've kind of defined a borehole success in our study as one that is okay or suitable for its original purpose, and that original purpose may change over time as mine workings become flooded, and or it's the targeted mine void, so it's at the roadway. For a success, you don't need to encounter mine workings for it to be a success. Obviously, site investigation boreholes aren't necessarily targeting a mine void, so they may not encounter one. And monitoring boreholes, they don't need to be in mine roadways. They can be in collapsed workings. You get the same water level. You may get slightly slower response times if you're pumping nearby. Whereas for operational boreholes, you don't have to be in mine roadways. Depends on what flow rates you require. For lower flow rates, you can not be in a mine roadway. You can be in collapsed workings. But for some of the largest systems, you need to be in a mine roadway or a mine void, so an underground shaft. So how do we assess success rates? We looked at a total of 564 boreholes around Britain that we use for monitoring and operational purposes. These are boreholes that are on British Geological Survey's GeoIndex, which is an online mapping service where they've got all their data, and it's using only the data that's freely available. We also updated the geoindex with our own boreholes that were missing and released confidential status on some of those logs. And part of the study, we determined various parameters from those logs and some bits of mine information, because sometimes not all that information is in on a borehole log. So we kind of looked what was a target type, was it a roadway, or was it total extraction workings? And did it encounter a mine void, or did it likely encounter a mine void? And what was the original purpose of the borehole, if it was known, and how deep was a borehole? And we also included other details, such as its known borehole diameter, exactly what was encountered during drilling. Did you find waste rock? Was the mine workings fully collapsed? And then was the borehole suitable for its original purpose? And we also looked at success rates of hitting those mine voids against various different aspects. So some results. Out of the 564 boreholes, 418 of those, around 74%, encountered mine workings. That's void and non-void. Sometimes you don't encounter mine workings because you've got fractured strata above the mine workings, or you go into a pillar of coal. Of those 564, 348 targeted a void or a part void, and on total, 60% of those boreholes encountered a mine void. In some areas, you get better success rates. I'll come on to that a little bit later. And 7% chance of success of hitting a targeted mine void when you're looking for one. And 87% of all boreholes were suitable for their original purpose. So just concentrating on those that require a mine void. So you've got water abstraction, discharge, coal mine methane extraction, mine heat schemes, and we're looking to get artesian flow rates. So you can see you kind of got quite good percentages there. You've kind of about 80% encountered mine workings, and about 9% of those that targeted a mine void encountered a mine void, and about 8% of those were suitable for their original purposes. So looking at the target type with success rates, kind of got targeted mine voids. You got pepper and store, you just under 50% success rates, and some of the roadways, you're getting more and more success rates. And if you're around the pit bottom, around the shafts, you tend to have a very good success rate because you've got very good saying on those roadways. And an interesting thing with depth, obviously most of the boreholes we looked at were less than 100 or 200 meters below surface. But as you go deeper, we have boreholes deeper than 400 meters. They have a 100% success rate. We've kind of got very few numbers, you're into kind of tens. That's more likely because they've got more modern mine workings and better surveying at deeper depths. So kind of what are some of the common causes for unsuccessful boreholes? Following from what David's mentioned earlier, I kind of broke this down into design and construction phases. So in design phases, you've got actually the mine plans. So what age of the mine workings, what age of the mine plans, and how confident are you in referencing those mine workings to surface and then getting a coordinate. You can also choose a pole underground target. So you may have some mine workings that you're trying to get mine water, but they're unflooded, or they've got perched water levels. You may come up with a poor design or a method for drilling that borehole. More likely if you're kind of an expert in drilling into mine workings. Drilling into mine workings can be very challenging if you've not done it before and you're not quite sure what you're doing. Or you've not kind of, as I said, you're not fully assessed the mine system properly. So you're getting mine gas or unflooded mine workings. During the construction phases, As David mentioned, keeping a borehole vertical is quite difficult. They tend to move around and quite often spiral a bit. So you get unplanned deviation. You can plan for deviation, so you can incline a borehole or direction draw these boreholes sometimes. If you're doing that, you need to be confident whether your underground target is. We found that kind of some contractors aren't used to going into mine workings. So when you start getting issues with fractured ground, loss of flush, it becomes a bit difficult to continue that borehole and go into the mine workings. But also incorrect construction or fine installation. At the Mining Remediation Authority, we tend not to put screens through the mine workings or gravel packers. We tend to case just above the target horizon and then go open hole. We sometimes put in a drop set casing if we've got weak strata like mudstones that may collapse. There's some of the factors for targeted mine workings and to help improve your success. Firstly, what's the type of mine workings that's been targeted? So on the right, you've got different mine plans. You've got an older mine plan on the top. That's kind of 1920s, 1930s age. And one at the bottom, which is 1950s, 1960s mine workings. So you're aiming for some of these tunnels or roadways, which are quite well surveyed, or you're kind of aiming some of these random lines. Before you get to the mine workings, you've got geology and mine workings that may be above your target. So what are you going through? Are you going through some aquifers? Are you going through some mudstones, fractured sandstones? Age of mine workings, as I said, so can you reference those to surface? You can also, with age of mine workings, get incorrect recording of those mine workings. So in some areas, you may think the mine workings are totally extracted, but in reality, they are pillar installed, and we found that in some of the borehole logs we've looked at. In Britain, you may get unrecorded mine workings. So before 1872, it was not a legal obligation to keep mine plans. So any workings before 1970s, we may not have records of those mine workings. But also the depth of the mine workings and drilling deeper can cost you more, but it can also mean you've got a better success. And you also have kind of mine gas risks, and you may have incorrectly assessed your mine water status. We're kind of to help success, we will go for a good assessment. It requires a good feasibility of your mine workings and expected drilling geology and your target. That is it. Any questions?
Great, thank you. Eileen, do we have